In 1821, Michael Faraday invented the electric motor. We're looking at a diagram of such a device. It consists of a pool of mercury and a conducting wire that dips into the mercury. Then there's a magnet that is fixed, and when current flows through the wire and the mercury, the hanging wire will rotate around the magnet. In the other version, the conducting wire is fixed and the magnet is free to move. When current flows, the magnet moves around the wire. Here's a model of a similar device. To power it, we have a AA battery, and then there's a disc magnet and a conducting wire that can rotate around the disc magnet. The wire hanging is on a little pivot so that it is free to move. When current flows through it, the interaction of the current in the wire and the magnetic field makes the wire go around the magnet. To explain how this thing works, we have to talk about the magnetic field that surrounds this magnet. If we insert the magnet through a piece of paper and sprinkle some iron powder around it, we can see that invisible magnetic field surrounding the magnet as the particles line up with the magnetic field. To illustrate what Faraday discovered, let's take a look at this diagram. It shows the magnetic field around the magnet and the wire that is dangling within that field. Here's what Faraday discovered. The magnetic field goes around like this. And what he found out is that when a current flows through that wire while it's in that magnetic field, it experiences a push. And the direction of the push, of course, depends on the direction of the magnetic field and the direction of the current in the wire. And one could learn what's called the right-hand rule to figure out what direction this goes. So if the magnetic field is coming out of the top, that means that the north is on the top and south is on the bottom. And on the bottom, the field would be going around like this. The basic principle that he discovered is that when a current flows through a wire that is immersed in a magnetic field, the wire will get pushed right at a right angle to this magnetic field. And once it moves around, then the direction of the push moves right around with it. Now, the reason we don't have mercury is that nowadays we have neodymium magnets that are made out of a conducting material. And when the wire touches the magnet, it completes the circuit and the current runs through the bolt, through the magnet, right up the wire like that, and creates current in the wire. So the wire has to touch the magnet to actually happen. The instant it makes it touch, it will fly around and maybe disconnect from the magnet, but then eventually it will swing back in and touch it one more time, keeping it going around and around in a circle. Faraday maintained the connection electrically by using the mercury, but he didn't have available neodymium magnets at the time. So now we can do the very same thing, but without the mercury. Okay, let me give you some pointers on how to build one of these things. All right, we'll disconnect the battery first. And let's start by putting a bolt in the big hole, screw into the small hole. And we don't want to tighten them down all the way just yet. Then we're going to make this wire that connects to the battery. It should be about a 1/4 inch longer than the longest side on the board. And then we got to make a little hook on it to go underneath the nut. And then we'll have to tighten down the nut. Probably have to use pliers, get it nice and tight. Then we'll bend that piece of wire around to make a connection to the battery. I always like to put a little bend on the end. You don't really have to do that, but it helps to secure the battery a little bit more. All right, next we got to make the hanging piece of wire, which is about the same length, about a 1/4 inch longer than the length of the wood. And that's going to be the piece that hangs down. It needs a little loop at the top to hook onto the little pivot point. Next, then we got to make the tall arching wire. So we're going to use the rest of the wire to do that, and we're going to first wrap it around the screw one time, and then tighten the screw down nice and tight to hold it steady. One piece of that wire then is going to go to the other end of the battery. So we've kind of created a battery holder essentially. And the battery will sort of fit in between there, and the tension of the wires is going to hold it in place. Now, to make the arch way, we just got to bend the wire into sort of an arch shape, and so that it hangs straight over that bolt. And bend it around, get a nice and smooth curve. And then we'll have to add a little loop onto the end of that to connect the hanging wire. So taking the pliers, just make a little loop right at the end. And then we're going to attach the hanging wire onto it. What we'll have to do then is pinch those loops together, not really tight so that it can still move. If you get it too tight, it won't be able to really swing well. So pinch it just enough to keep it from falling off. And then the thing can freely swing. All right, take a minute or so to just get your wires all straightened out and nice and vertical and stuff like that. You want the hanging wire to be pretty close to directly over the bolt, but not touching the bolt, just above the bolt before we put the magnet on there. All right, if you don't get it exactly in the middle, that's probably okay, but as close as you can. Just bend it around, twisting and so on, until you get it pretty close. The last thing to do then is to attach the magnet. And then the battery. So once the magnet is in place, then we can insert the battery. And it starts to rotate. Now you might play around with it a little bit and see what happens if you, for example, switch the battery around. And the wire spins the other direction. If you flip the magnet over, the wire will spin the other direction once again. All right, there is a model of Faraday's electric motor.